Hello, Nautilus Live audience. My name is Jamie Zachariah. I am the digital media specialist here with the Ocean Exploration Trust, and we are broadcasting live from aboard EV Nautilus in Hawaiian waters. This event is the first in a new live series connected to our brand new From Shore to the Abyss program, which we are doing in partnership with the National Geographic Society. And this program brings OET's expedition experience to the shallow waters for coral reef conservation, for new discoveries, for connecting the shallow to the abyss for our global ocean conservation. And these panels that we're having are opportunities to meet and engage with the scientists aboard From Shore to the Abyss expeditions. So you can ask questions and hear about the exciting research going on right now. We're super happy to have you joining us, whether you're on Facebook, whether on YouTube or LinkedIn. You can submit your comments for our panelists. We might do some throughout, and at the end, we'll definitely open it up for more comments. So don't be afraid to ask. And just so you know, we've launched this program with 5 different project teams, but today we are speaking to the shark research team, and we're going to learn how they use artificial intelligence for shark conservation. So, to kick off this event, I am super happy to pass it over to Shark Team member and educator extraordinaire, Kelly Kohler.
Thank you, Jamie. And hello, everyone. I'm grateful to be a part of the Shark team and help facilitate this conversation about how we're harnessing the power of computer science to further shark conservation with artificial intelligence. In artificial intelligence, computer programs are written to perform tasks that normally require human intelligence, such as visual recognition and decision making. As you'll hear, the AI team SharkPulse is using images and video to identify sharks and classify them by species. This ship right now is just off the coast of Maui in Hawaii, but I am seeing folks in the audience start to chime in. We'd love to know where you're from. And thanks so much for being with us today. First, I'm excited to introduce Sarah Khalid, a senior research fellow in biomedical data science and health informatics at the University of Oxford, where she leads the Planetary Health Informatics Lab. Her incredible research focuses on big data, artificial intelligence, and the health of humans and the planet. Her work with National Geographic and with us here on the Nautilus is about machine learning and remote monitoring applied to sharks, which we will hear about in a bit. Sarah, where are you connecting from today? And tell us a bit about AI.
Hi, Kelly. Thanks. Hi, everyone. It's absolutely great to be here. I'm connecting from my lab right here in Oxford, where we are about 10 hours ahead of Hawaii time. So it's nice and late in the night, and very happy to see everyone join in today.
All right. So great, Sarah, that you're here. Can you tell us a bit about your work with AI?
Absolutely, yeah. I mean, where does one begin? I guess maybe the question is who's heard of AI, or maybe the question is who hasn't, rather. So terms like artificial intelligence, deep learning, machine learning, uh, maybe these ring a bell with some of us. But even if not, one thing we've all heard of is the human brain, right? Um, and that's basically, believe it or not, something that AI is very similar to. So, artificial intelligence, or AI, was originally designed to mimic some of the working of the human brain. In fact, one of the most popular artificial intelligence algorithms that we know of in use nowadays is called neural networks, which is quite similar in design, or intended design, to the human brain. And I guess maybe one area where artificial intelligence mimics human intelligence is the human brain's ability to recognize patterns. And artificial intelligence here is at an advantage because of its ability to process what's known as volume, variety, and velocity. So large amounts of data, and which for us as humans may sometimes not be easy to recognize or discern with the naked eye. So yeah, so I think artificial intelligence is a bit using artificial intelligence is sometimes a bit like being an explorer and making discoveries, except you're doing that with data. So you're probably thinking, like, how does it all work? Now, some of you maybe not old enough, but there was this movie called The Matrix, and what it shows us is not far off from reality. So the computer inside, when it works with artificial intelligence or machine learning, sees everything literally as numbers, so pretty much as zeros and ones, including us. And that helps it to help us look for patterns that we can't quite see with our naked eyes, and that's what is known as pattern recognition. It then helps to do things like make predictions about future scenarios, and to do it a bit better sometimes than alternative or traditional methods in computer science. So maybe I could give you like a little example from my lab here in Oxford. So a lot of what I do here is, along with my research team, is to work with a lot of huge amounts of, or even terabytes of health and environmental data. For example, from entire populations, human populations, from National Health Service or the Met Department. We look at weather data, and with the use of AI, we can kind of understand which populations, for example, are more at risk of certain diseases, tease out patterns within them, and that all in all helps ultimately to take preventative actions, provide better care, helps even governments to make better policies and decision making for doctors and so on. I guess what you guys are probably wondering about at this point is what is any of this got to do with sharks? So,
Yes. Oh, please tell us more. Yes. Sorry, Sarah. How does
absolutely.
this translate to shark conservation? It's amazing.
Sharks, as we all know, and as Francisco and Jeremy later on will tell you more about, are, they've been around since before the time of dinosaurs. But today they're endangered, and to help them or save them, we need to learn more about them and this biodiversity loss. And again, it's not always very easy for humans to see things and tell them apart. Where AI comes in is one of the things that AI is particularly good at is looking at images and looking for patterns within images. And if you at this point are thinking of your smart devices and face recognition technology within that, yes, it's not very far off from that. So, working with AI, we can recognize which type of sharks, for example, are prevalent in a particular environment, and how other populations are evolving or dwindling. Um, and a simple task, such as recognizing and counting sharks in a video frame, can help move some of this research forward. Maybe we can look at an example of this to help understand. So what we're looking at in a screen right now, any guesses for which type of shark that might be? I can maybe give three options here. So are we looking at a tiger shark? Are we looking at something called a bull shark or a hammerhead shark? And yeah, I guess, I mean, the answer in this case was bull shark. But the point is, sometimes it's not easy to discern one type of shark from another. It's not easy to discern whether it's a shark or coral reef. And sometimes it may be too dark to see. So um, we did have another footage of a little sneaky tiger shark in this case come out of the depths of the water in the background. Um, and and there you go. With the AI tool, which is drawing boxes around the shark as it detects it in real time, it is able to kind of I both identify that the object it's looking at is actually a shark and not, for example, a coral reef or a different type of fish, and it is then able to make predictions about which type of shark it is in particular. Um, so it, this is what the AI tool has been kind of developed for this particular expedition, which Jeremy and Francisco will tell us a little bit more about. And then sometimes, there's another footage that we have, which shows that there's sometimes just too many fish to look at or process at, in one go. Again, that's an area where if suddenly lots of exactly shark pop up all at one go, and we're wanting to see which one it is, that again is something that the artificial intelligence technology that's been developed and used in this expedition can help with. um, so that's a bit about the AI, Kelly.
Fascinating, Sarah. Thank you so much. And we did have some audience members call out bull sharks, so they were right on. There was just a little bit of a delay there. And we do have some questions from the audience for you before we let you go and move on to the next panelist. We are wondering, how did you get into this field?
Yes, so I actually, I mean, um, if I'm honest, I grew up in the urban jungle. So I'm from a city called Karachi, which is is huge population density and all that. But I mean, in it's in a city in a place called Pakistan, which is surrounded by five of the tallest peaks in the world. So I mean, it's impossible to not to be inspired by the nature all around you, and that's where I initially sort of got interested in the idea of applying what I have learned as an engineer, which is artificial intelligence, to helping to protect the nature around us and do conservation efforts. So I was approached by local conservation agencies when they knew I do artificial intelligence here at Oxford. I then got in touch with Francisco's team at SharkPulse, and the rest is history.
Fascinating. And that's so wonderful. I'm so glad that you are doing this work, and I hope it continues for sure. Um, and excited for the future. We have a comment and another question from the audience. A comment from Blue Pajamas. I saw some of this AI at the Engineering Expo at Oregon State University, and it inspired me to make it a career, your career path. So that's awesome that there's other work, people doing the work out in the field connecting to this presentation today. And then we have another question, wondering for Sarah is if you know if anyone is applying this technology to whales.
That's a very good question, and I wouldn't be surprised if someone was, to be honest, because one of the beautiful things about science is that whenever you come up with a great idea, almost always there's someone else in the world who's also thinking of it. So wouldn't be surprised. I know that Francisco's team here in Shark Pulse, together we are kind of doing this for sharks, and whales are equally, some types of whales are equally endangered, as well as turtles, for example. So we know of some groups working on turtle conservation using artificial intelligence, and the concept extends beyond conservation of marine mammals into land-based mammals as well. So this is kind of just scratching the surface, really.
Yes, and I have a question for the audience then to think about. So now that Sarah mentioned a couple other species where AI is being applied, we have people connecting from all over the world. How do you think AI could be used in your area where you live? So if you have an idea for that to pop in the chat, we would love to connect and hear about that. Meanwhile, we will bring another member of our team, Dr. Francesco Ferretti, to the forefront. He is an assistant professor of fisheries management and conservation at Virginia Tech and the lead investigator and funder of the Shark Pulse initiative. He is a quantitative computational ecologist specialized in research synthesis. That means he combines ecology, statistical modeling, and data science to approach questions on animal abundance, species interactions, and the structure and function of large marine ecosystems. He's been working on the ecology and conservation of sharks for the last 18 years. Francesco, great to meet you. And how and when did you become first interested in sharks?
Uh, Hello, everybody. Hey, thank you, Kellen. Great to meet you. I became interested in shark when I was really young. I have to say that the infamous Jaw movie um, with its fantasy, had a negative impact, may have contributed negatively to the conservation of sharks and to their overexploitation. But on me, it planted the seed. I was I was fascinated, entertained by this movie. At the same time, I was scared as well. But there was this marine biologist, Matt Hooper, who was very charming, and the guy was called by the city police chief to try to identify and hunt this rock shark. Now in Jaws there is a lot of fantasies, but I have to say that on me I had a positive effect, at least stimulating my interest in sharks. And then when I went to college, I matured my understanding. I had a more mature understanding of sharks, a more mature attraction for these animal. And really, when I went to do my PhD in Canada, and I was working on shark conservation and research, I really appreciated their value and understood the importance for the ecosystem, and also their dangerous conservation status that they are facing at the moment.
Oh, awesome to hear. So, audience question that we have is to um, wonder, Francesco, if you think this Shark Pulse tool could help identify new species, or at least the AI model being developed.
Identifying new species is difficult. I mean, the model can fail when there is a new species because it cannot identify unknown item or unknown species. We are teaching the model. We are teaching the brain of the shark detector. Then later, Jeremy will illustrate with known species of sharks, and so it it may be just flag us species that we don't know a lot about, and then these will then stimulate more investigation, and who knows, it may also lead us to discover new species.
Awesome. And audience question for the audience to think about is, how do you think sharks affect everyone? And I would love to hear, Francesco, you riff on that a little bit for us, because you've been doing this work for so long. What keeps you going? Why are sharks so important to the world?
They are very important. Sharks are they they range across large distances. They are big. They are at the top of trophic chains. They are predators on many ecosystem components. And so, by doing this, they are keeping in check many components. The over population of fish and other marine animals, and so they help stabilize, and they help making sure that the ecosystem function in the right way. We know a lot about. We are starting to know a lot about their ecosystem function and why they are important for the ocean. We also understand that we still have a lot to learn, because we are seeing that once you remove sharks, you are observing the ocean are affected in unpredictable ways. The overexploitation of sharks have caused fisheries to collapse, have caused marine ecosystem to become more hysteric and vulnerable and more variable. And this is not good for fisheries, also for our ocean use and for the from the services that we are getting from the ocean. So there are multiple ocean processes and services that they can affect, and so that's why we need to understand clearly what's the real ecological role and what's the real value for the ocean. The dangerous thing is that they are really endangered. 1/3 of their population are endangered with extinction. For many other, we have many information gaps, and so that's why we need to fill these information gaps for these animals.
Absolutely. We have a couple questions wondering the nitty gritty about AI and who makes it. And we will get to those in a second with our next guest. But first, before we do, wondering, Francesco, if you could give us a high level overview about SharkPulse, since you are the founder of SharkPulse. What is the organization all about?
Yes, thank you, Kelly, for this question. As I introduced just a moment ago, like many shark populations are in decline, and they are declining worldwide because they cannot sustain fishing from global fishing fleets. They were abundant and historically caught as a bait catch, as an accessory catch. They were not wanted in fisheries, but they entered their catches in conspicuous numbers. Sometimes, like if you go like swordfish fisheries or longlining, they were catching more sharks than swordfish and tunas in the 60s or in the 70s. And then since the 1980s, their exploitation has escalated notably because of the shark fin trade. It is estimated that the number of sharks killed each year for this trade ranges from 23 to 78 million. But the total mortality of this group is far higher than what we know because with estimates that are surpassing 200 million. They continue to be bycatch of global fisheries. They are targeted for their meat, and there is a notable portion of their catches that are done illegally, and they are not reported. So as I mentioned earlier, the World Conservation Union estimates that 1/3 of elasmobranch species are threatened with extinction. Sharks are the most threatened vertebrate in the ocean. But the more insidious problem that we are trying to address is that for most shark species, there is still an important knowledge gap in their ecology and biology, even for the most abundant species. And there is not enough data on abundance, distribution, and mortality to produce a robust assessment. So we really need to fill this information gap. And because starving shark is expensive and impractical over large regions, we need to find alternative approaches. So SharkPulse respond to this need. This is the platform that we created. This is a crowdsourcing initiative aimed at collecting images of sharks worldwide and converting them into sightings. This idea came to me 8 years ago when I brought my parents whale watching in Monterey Bay. It was a spectacular day with more than 4 humpback whales in the area. 2 of them approached us, and immediately all visitors leaned on the boat gunwales to take pictures. What struck me the most was that almost no one on board had a regular camera, but most of them were using smartphones. And when you take a picture with a smartphone, you store other auxiliary data on your image. These include geolocation, time, other technical parameters that can be used to generate useful species abundance and distribution data. So today, Connected World offer us an unprecedented opportunity to harness crowdsourcing, gathering data on species abundance, distribution, behavior, and other aspects. Think about these facts. There are 8 billion people in the world, almost 8 billion. 60% live near to the coast. 1 billion people travel annually to international destinations, and many of which are marine and coastal, and there is no corner of the ocean that hasn't been reached by tourism. And there are more than 6.5 billion smartphones subscribers globally. This is 80% of the global population. By tapping this observation effort, we can truly go from data deficient to big data from sharks. So SharkPulse aims to create the biggest database of shark photo sighting by warehousing all shark images available online. And this project started as a conventional citizen science initiative, piggybacking on other programs. Initially, we developed a couple of mobile applications allowing users to send their images directly to our database. Then we created web applications allowing users to upload images from their digital archives. And finally, we encouraged users to share pictures on social media like Facebook, Twitter, Instagram, which we could then mine. These data streamed directly into our database to be organized, elaborated, and reshared with users for data enrichment. But this approach, which is a conventional, as I say, citizen science approach, needs effort to nurture and boost participation. People may download your app and submit a few sightings initially, but then this participation fades down. Nonetheless, this effort can generate data, are really useful for research. However, our real frontiers now is automation and artificial intelligence. SharkPulse is now transitioning from asking data from people to mining information. We are going beyond citizen science by boosting and spinning our core database with automation, web scraping, crawling, and mining, and using artificial intelligence. We still need help from people for data validation and expertise, but the platform is expanding, developing, and becoming increasingly cybernetic with the creation of many automatic data streaming pipelines and data processing models. I like to think of it like it's a robot that is taking life and at some point will take us over. With this approach, we can inflate this database what order of magnitude and to the millions of images, and really we can truly support research and conservation with lots of information that so far have been scarce for these animals. So that's my nutshell for our program.
Fascinating. I love how this idea launched from an personal experience with your family and then grew into what we now know as SharkPulse. We have a question from a viewer. So I can contribute myself to with my phone.
So,
Francesco, you
yes,
want to take
totally.
that?
You can. So initially, we have put effort in the phone. You can definitely go in our website and submit your images also from your phone. And we really like you also with your phone to go in our validation apps so that you can help us validate a lot of data that we are streaming and we are sourcing from other social networks. So totally, you can help us. You can send images to our platform. You can help us identifying images that we are sourcing from elsewhere, and you can get points. And then you can be listed in our leaderboard of all of fame list of top contributors. And sometimes every once in a while we can also organize competitions across the planet. Last summer we had the first shark photo hunt. We distributed iPhones and other prizes for people helping us. So please
Yeah.
help us out in this
You can
mission.
get a prize for helping with citizen science. I love it. That's fantastic.
So basically, what you're saying is no matter where you live, whether you get to go out and see sharks or not, you can log in and be a shark scientist and participate
You
in
can
citizen
be
science through this app.
Totally, Jamie. Yeah, you can be a shark sightings. You can increase your knowledge on sharks. You can be a top taxonomist if you keep using this platform. So yes,
Awesome.
everybody can give their contribution.
Thank you so much, Francesco. And we have an audience question, something for our audience to stew on and maybe report back. So this is really a fascinating citizen science project. Is there a citizen science project in your area going on that you would also like to share in the chat? Because we are all connected to this conversation and excited to learn more about other citizen science projects going on too. And we'll move ahead to our next guest, Jeremy Jenrette, who is a PhD student in fishery science at Virginia Tech, who designed the AI. So we're going to get really down to the core of this system. He designed the AI for detecting sharks. His research and professional background is focused on data science, machine learning, population genetics, and marine ecology, with a special interest in sharks. Jeremy has developed and published software for improving taxonomic classification of shark species with artificial intelligence. Recently recognized for his mentoring achievements, he was awarded the Bird Sheldon McGuinness Fellowship. Jeremy's work has taken him to remote salmon fisheries in Alaska and shark surveys in the Sicilian Channel. Jeremy, how did you get interested in shark conservation?
Hi, Kelly. Yes, that's right. I grew up, it's a funny story how I got interested. I grew up as kind of a gamer, and I was particularly interested in Pokemon. What I loved about those games was the mystery of discovering a new Pokemon and adding them to my roster. And believe it or not, this is very similar to finding and adding shark species to a classification model that you've programmed to identify those species. But I won't give Pokemon all of the credit. When I was growing up, I was also in love with gaming, or excuse me, fishing. And every year, my family would travel to the Outer Banks in North Carolina or the Chesapeake Bay here in Virginia. That's a striped pass right there for me when I was younger. And those were really the two areas of my life where I found my passion for fishery science and eventually shark conservation.
Awesome. So can you tell us what are the latest updates with the shark detector and this developing technology?
Sure. Yeah. So the shark detector was created to ultimately boost surveying methods and increase shark conservation. And so, like Francesco was talking about, sharks are charismatic top predators of the marine environment, and they inspire a lot of funding for research expeditions such as this. And so, monitoring techniques like the shark detector are continuously evolving so that we are better equipped to understanding shark population behaviors. However, there are still information gaps in shark knowledge that make it difficult to develop conservation policies for them. Sharks have few offspring and massive home ranges. They span all of the oceans, and this makes it difficult to monitor them when they're so spread out. And so on top of that, millions of sharks are killed each year, unfortunately, by commercial fishing pressure. And so the question of this project became, how can we boost the positive aspects of shark conservation while minimizing the negative aspects? And that's where artificial intelligence like the shark detector can really help out. So this is a growing area of research that can ultimately revolutionize how we monitor and interpret the marine environment. So stock assessments are enhanced by AI. Even large-scale commercial fishing uses algorithms like these to locate themselves with satellites, monitor the fish they've caught. If you've ever seen a commercial fishing vessel, or if you've been on one, sometimes they'll actually have cameras perched in the balconies to identify and count the amount of fish they've caught, so someone doesn't have to write it all down on a clipboard and do it manually. And so there are many cutting edge tools and evolving technologies that kind of make our lives easier when interacting with the ocean. And I really think the shark detector is one of those valuable tools that can automate a lot of different tasks and make our lives easier. And so the shark detector is ultimately is a package of Python modules designed to spot sharks in videos and images and then classify them to the species level. And so this app has a lot of different strengths, especially when conducting underwater research surveys focused on sharks, but it can be used elsewhere as well. Fishermen can use it, tourists, photographers. If you at home have taken a picture of a shark like we were talking about and posted it online, there's a chance that we at SharkPulse have actually found that image and added it to our database. And so we developed this app as a web application on SharkPulse on our website, and as a downloadable app that anyone can use. And I've actually been developing this app over the past 3 months just at home because I actually was injured playing soccer recently. I tore my Achilles tendon, which is not a fun injury. And so I did a lot of coding in the meantime. So here's an infographic of just how the model works behind the scenes, behind the UI. And so it'll load the models, and then it will start predicting upon a video or an image what shark species lie there. But I suppose at this point you're seeing this code and all of this, you're going to wonder, how does the shark detector actually work? How does it load these models? How does it build them? And so developing this application was not a straightforward process at all. It was pretty challenging because there are over 500 different shark species, and they look very different from each other. A hammerhead and a whale shark don't look anything alike, but they need to be differentiated somehow within a model. And so we approach this problem by developing 3 main algorithms. And so the first algorithm is an object detection model, which actually looks for shark features in an image and then draws a box around those shark features. And then the second step is a binary model that you can't really see here, but it works behind the scenes, and it evaluates a value between shark and non-shark. And then the third step is going to be a little more complicated because now we need to identify the species of the shark. And we broke this down into 2 more steps, where first the genus of the animal is predicted, and then a separate species model predicts that species. And so the shark detector is currently able to identify 47 species of sharks, and the other species are considered data deficient. And so we need to collect more images for them. We need to dredge social media and online archives for that media so the shark detector can recognize them in the future. And so in order for the shark detector to be good at its job, it needs to be trained like any artificial intelligence, right? And this is where I kind of draw the line between our app and games like Pokemon, because the shark detector was trained with over 66,000 images of various shark species. And so it sort of becomes like the Pokédex, where it keeps accumulating all of this knowledge of the various species with their images, and it never forgets them. It can only grow smarter with each image it collects. And we found these images by exploring social media and online archives like Instagram, YouTube, Flickr, and Facebook. And we have organized these images within SharkPulse to be used as training material for the shark detector. And so the shark detector is good at its job, but it can always be better. And that's the big takeaway I've learned from this project, is that, it's good, it's fine, but it can always be better. There's always room to improve. There's always ways to tweak the models so that your accuracy is a little better. And so that's why at SharkPulse, we like to involve people with the validation monitor, like Francesca was talking about. This is where we have a platform on our website for citizen scientists to get involved. Come out, check out the shark sightings that we've scraped from the internet, and see if they're actually shark species that you know of that you can validate for us. And so to complement this, we also have created an identification guide with pictures of shark anatomy, labels, good infographics for people to differentiate shark species. So even if you have a computer do it for you, it's always important to understand the different taxonomic branches, because you as an individual should learn more about the shark species and their role in the ecosystem. But the great thing ultimately about the shark detector is that it has many applications for these animals to increase conservation and management. And so we can gauge population abundance with autonomous drones, underwater videotaping like we've seen here, and we can cut down on illegal fishing activity by monitoring seafood markets and industrial fishing. And so we've put a lot of work into developing this application so it can be used in many different scenarios. And personally, I'm very proud of what it has become, but I know it has so much potential to be more and fundamentally transform how we monitor sharks in nature. Detection algorithms like these are being used more and more now for observing all of life, and that's really encouraging for conservation in general. And so I will continue to work on the shark detector to boost its capabilities. And I hope you at home can help me out at SharkPulse in helping us find more records of shark sightings out there in the world so we can better understand these really awesome animals.
Oh, that's awesome. And yeah, we're working hard on the Nautilus in teamwork with Sarah to get some grub footage for this project to contribute. So just to summarize, there's three main modules as part of the programming, all created in Python for anyone interested in checking that out, and any computer science fanatics out there. And they basically ask, first, is there something in the view that could be a shark? And then, is it a shark? Yes or no? That's step 2. And then the third step is classifying by species. We have an audience question wondering, how specific can it get? Do you foresee it getting specific to enough to identify injuries or abnormalities on sharks or individuals?
Yeah, definitely. If there's an image of it, we can train a model to classify what kind of injury or anything like that. Yep.
Awesome. That's great to hear. So this technology is just going to continue to grow, and we can all help by continuing to engage with the SharkPulse web application and contribute images. Thank you so much. That rounds out our normal part of our panelists. And we're going to jump into a section on audience questions, but I do have one lingering question that we did not get to for Sarah before we do that. So somebody had been wondering, nature and you had mentioned your inspiration came from nature and that you work in AI. And the comment was, those seem to be so opposite. So how do those work together for you? How do you draw? How did your inspiration from AI come from nature? Can you talk a little bit more about that?
Yeah, I'm very glad you asked that question, actually. Yeah, I think it's really simple. I think you can look for the good in everything and anything. So, that's the same is true for artificial intelligence or any technology. So, when I had the option growing up or doing my engineering degree, whether to focus on building radars or to work with ways of getting people out of hospital faster by monitoring their vital signs, I chose the latter. And that's the same for conservation as well. The more I got exposed to the natural world around me and the importance of trying to kind of preserve and protect it more and more for our future generations, even drawing some inspiration from my kids now that I have kids. It became more and more clear that whatever it is that I'm skilled at doing, if it's engineering or artificial intelligence or data science, then there's a way to it is possible to find a way to apply that for for good. One of the programs I lead here is artificial intelligence for good, and I think it may sound like a misnomer, but actually there's a lot, as we've seen through the program, what Jeremy has explained, and Francisco as well. There are ways to use artificial intelligence for conservation. I mean, this is only the starting point, right? I mean, as we've been saying, this is about kind of in the first instance trying to help the human eye recognize and count and monitor shark populations in the ocean, and only when we have a good sense of that can we start to kind of make efforts towards policy making to save them and conserve them being endangered species. um, so all in all, I think to say that if artificial intelligence and nature may not necessarily be contradictory and can actually go hand in hand. And I would actually encourage everyone on the call to kind of, especially the younger members of our kind of call here today, to kind of think of ways to, if you are inspired by artificial intelligence, there's nothing stopping you from thinking of ways to kind of use it for making positive contributions in the world around you.
Thank you. That's great. So what's really exciting is that out here from EV Nautilus, members of the Shark team are doing the research right now. They're in fact on the boat right now, on the dive boat away from the ship. And we've been out here for almost a week, sending the dive boat out to deploy BRUVs, the baited underwater video cameras. And this video that you're about to see is our first shark captured on one of these cameras. It is a female gray reef shark. And what's great is that she comes back and back again to kind of inspect the bait, to give us some beautiful views of her fins on camera. And this being the very first image, like video that we have here, was just really reaffirming for all of us on board to say, yes, this is so exciting. We're getting the footage that we need to incorporate into SharkPulse, into AI. So yeah, our teams are out there. They're doing BRUV deployments. They're also doing eDNA collections. And Kelly happens to be an expert on that.
I would use the term expert lightly, as I'm just getting started in that. But yeah, we are taking samples to cross-analyze with the BRUV footage. So it's always good to gather more data and different types of data. So by diversifying our methods, we're hoping to gather the most information we can about the shark species abundance and diversity in this area.
Yes. And we do have some questions about the role of National Geographic Society. And so we have partnered, we being the Ocean Exploration Trust, who own the EV Nautilus, we have partnered with the National Geographic Society to bring all of our expertise and our knowledge and our resources together to allow these teams to do the research that they do in shallow waters that will also be applicable to deep water conservation. So these research teams were highly and efficiently picked by the Nat Geo Society. And together we're just kind of paving the way for a future expeditions in this program that allows us to connect all of the global ocean.
All right. Yes, and that's a great summary. And I think we have some more audience questions that we can pull up here. So time for discussion. So questions for our panelists. It's kind of open target for any of the three panelists. We will relay some questions and everyone can jump in.
So I see a question about how do we deploy these BRUVs? And that is a question that we can answer with a video.
All right, so this is what we're looking at here is kind of a little pile of BRUVs. The ones with the red are shallow BRUVs, and the ones with the black steel or gray steel are deep water. So we're doing shallow deployments of about up to 40 meters and deep deployments going up to 200 meters. The gray reef shark footage is from one of our deep deployments. So that was about, between 100 and 200 meters. What you're seeing now is the gear being hauled onto the dive boat where these BRUVs get deployed from. We also incorporate another form of data collection on some of these dive trips. We try to do underwater visual census surveys. So that would be with cameras and in scuba and note taking to just kind of get a general habitat assessment for the area.
Yeah.
The Bruvs have a GoPro camera embedded into a water protected canister. So that was like the tube or canister type thing on the top of the metal frame. And then there's a battery pack in there. So we turn the cameras on while we're on the surface of the dive boat first. Then we send them down. They sit on the sea floor. Hopefully. And sometimes, as we had a couple wander away yesterday with some very windy weather, one of them did not stay on the seafloor, but the ideal is that they stay on the seafloor and then record for 90 minutes is the goal. For our research team, 60 minutes of footage is needed. And of course, the SharkPulse team gets the selects from that. Ideally, though, part of the goal of the project is to reduce the amount of time for a human to review all of these hours of Bruv footage. So ideally, it would be really cool to be able to send all of the video footage to a computer to have it analyzed so that human eyes don't have to watch for hours and hours and hours, although that is kind of fun in the beginning.
Yeah.
But
Yeah, we have an audience member asking if there are live feeds of the deployed cameras. And no, they are GoPros that we need to collect and then download the videos off of. And to be honest, it might not be particularly exciting to watch if it was live because as you see, the one shark video was after maybe 5 videos of 90 minutes each. So it's not just a shark highway, so we do provide the best of footage that you can see if you continue to follow us on social media. But no, this is not something that's done live. It's done with our data engineers.
And at the
And
same
then-
time, I think it might be worth mentioning that, to provide this capability for onboard processing is why, and I'm very glad to say, Jeremy, you broke your foot in the summer, to allow for this to happen is we now have a local version of the AI tool, which is kind of run as a front end to the huge SharkPulse engine, which anyone can download and run on their local laptops, whether that be on board the Nautilus, as Kelly and team have been doing, or whether it's in my laptop here, or and I think that is really available as well. And there's always the option to kind of use the SharkPulse web server to process images as well, which is also something that the onboard team have been, having been having the facility to use as well for this.
Wonderful, thank you. Jeremy, we have a question for you. Well, it's a 2-part question. The first is there a certain species of shark that's particularly easy or particularly difficult for the AI to identify? And then the second part of the question, the audience is dying to know your favorite Pokemon.
First question. I've noticed that the tiger shark is very easy for the shark AI to classify, mainly because of the stripes on the body that are pretty unmistakable, and the fact that we have a lot of images from tiger sharks coming in. And favorite Pokemon's got to be Pikachu. Come on, it's the best.
nice. All right, we have another question. Are these Bruvs the only Bruvs in the world? No, Bruvs are used frequently around the world, and actually Francesco does in different places of the world as well. So yeah, Bruvs are frequently a frequent tool used. One thing that I thought it was cool to learn about Bruvs is that our team PI, Ariana, built most of the Bruv when she got from the Philippines to Hawaii. So she planned everything out and then had to finish the construction because they are pretty bulky and hard to ship for it. So she had to do a lot of the building right before we started on our expedition. And I thought that was interesting. Francesco, we do have a question too from the audience. How many species of sharks are there?
There are about 560 species of sharks in the ocean. and also in rivers, because there is the bull sharks can go also in rivers, and so it's a brackish species. So there is a lots of species of sharks, and that's what makes challenging the task of identifying sharks. There are so many species, and that's why we need to increase our data, training data, on telling the computer and teaching the computer to recognize them. Many of them are very, very difficult to distinguish between one another, especially the requiem shark, which are the conventional shark-like species, the one like we were looking at. That, yes, the bull shark is part of the requiem shark. There are many species on this in the genus Carcharinus, and we know how to recognize half of them. The computer recognize half of them, but another half they are data deficient, as Jeremy was saying, and so we need to boost our effort in collecting more images for these species.
Awesome. And a question from Top Jake: how do you get the grubs back to the surface? They are connected with a buoy, so good question. Yes, they're connected with a fender, and then we hand haul them up. Fortunately, the dive boat that we've been using in the Maui area has also a winch on it, so make that process a little easier for those deep deployments. So that's been lovely. And we have another question: are there other ways to detect sharks besides using a camera? So we are doing the eDNA, or environmental DNA sampling. So we're taking volumes of water and filtering them and sending them off to a lab that can process them for the DNA. And we're hoping to detect sharks that way as well. But for Francesco or Sarah or Jeremy, are there other ways that you know of to share besides using a camera or video footage that you know are good ways to detect sharks?
Well, a definitely good way is to rely on what fishers are seeing. Like there are millions of fishers around the planet that they are working, and they are seeing what we are not seeing, and so and they are recording their catches, and that's why like a tool like the shark detector in SharkPulse is it may also be useful and increase the capability to use this fishery data. So far, we have been relying on what fishers were telling us. And sometimes fishers may not tell the whole story. They may also be challenged by the task of recognizing many species of sharks, as I was mentioning. In the Carcharinid species, they are really difficult even for a trained eye. And so having a tool in a smartphone that can also they use to compile and to logbooks and record their catches will increase their ability to report catches and our ability to manage fisheries from by using the data that they are giving us.
Great. Thank you. I have a question for Sarah. So you explained that you came from more of a medical background with the AI and the programs that you developed. What has been the most surprising or interesting thing about making the transition into shark science for you?
Yeah, I mean, everything. I think if you think about it, it's kind of like a continuum more than a pivoting. Working with large volumes of data, whether that's like human health data or shark health data, is all the same to me. It just is kind of fascinating just to see, some of the actual kind of marine mammals, in the real form in the water, and I think the fascination just doesn't stop with all of that. So for me, I think it's more of like a continuation and extension of planetary health, to go from working with data on human health to go to working with data about the planet's health. Because ultimately, if we are to kind of improve lives for humans around the world, then we need to kind of fix the problems that we've created for the planet, and beautiful species like shark in it.
We're
Great.
all
That was a
connected.
wonderful
We're all
answer.
really part of one big ecosystem.
Love that. I wanted to give you all a quick view of the back deck of EV Nautilus, where some of our team members and the crew are out there preparing various equipment that we will need throughout the day. You can see Ruby, our red boat here, that transports our team from EV Nautilus to the dive boat and all of the equipment. And then also I'm going to show you a peek inside the wet lab. And this is where we analyze samples. In this case, the eDNA samples. We were just analyzing some last night. Kelly gave us a great demonstration. And also where we store the bait. So don't open that fridge unless you want to get a good whiff.
Very stinky. Yep, those orange containers are wicked. That has all the bait for the pros.
So we're coming up on time now. I think maybe we should end with kind of a final thoughts, final messages that we want to leave our audience with, short and sweet. Sarah, why don't you start us off?
Not so much of a final thought, but I have very specific instructions on telling you guys what my daughter's favorite shark is, and actually there are two of them. So the cookie cutter and the lemon shark. So let me end with those thoughts from my daughter. Thank you.
Thank you. Those are great choices. And Francesco?
Well, yeah, again, yeah, same as here. Like, I would say, if something like one take-home message here is that, especially for young people or students in the middle school or high school or even primary school, learn how to code. It is very important. We are going in the communication big data revolution. We are submerged with information. They are still unstructured. They are still not warehoused in data sets, in pieces of data that we can use for making things good, like Sarah was saying. And if you can learn when you go to school, you can learn how to write, you can learn how to read, but now it's very important you learn how to code, because you will be a superhero. You can do stuff, you can do things that a few years ago were unthinkable. And so I wanted to leave you with this take-home message.
That's wonderful. Thank you. Jeremy, any final thoughts?
Yeah, definitely. Just want to reiterate all of that. I was not a coder 4 years ago. I had no experience in it, and Francesco kind of just took me under his wing and taught me everything he knew, and I started working with collaborators, and I really developed a knack for it. It's definitely brought me all of this way. And I also would like to say my favorite shark, which is the megamouth. Very rare species, less than 100 have been seen, and they look like someone tried to make a paper mache of a shark.
What a great description. Kelly, is there any final thoughts?
I will contribute my favorite shark, a Greenland shark, to the conversation. I think it's so cool that they can live so long, and I love cold water, so love it.
It looks like we represent the diversity in sharks with our favorites here. And unfortunately, that is all the time we have today. So I want to thank the team so much for sharing your passions, your research, introducing us to your work on board EV Nautilus and beyond. And it's a wonderful introduction to our From Shore to the Abyss program. And to all of you joining, thank you for tuning in. Thank you for submitting your questions and your comments. This event and all of our previous webinars will be available to view anytime on our website, nautiluslive.org. and on YouTube. And we want you to stay tuned for our next event, which will be Friday, September 23rd at the same time. We'll be connecting with the marine mammal team who are currently doing bioacoustic research on Hawaii's whales and dolphins. And that event is called An Ocean of Sound, Underwater Noise, Ecosystem Health, Noise Pollution, and What We Can Learn on this expedition. Until then, we encourage you to follow along with behind-the-scenes looks into expedition's progress. Stay connected to ocean exploration through Nautilus Live on Facebook, Instagram, Twitter, LinkedIn, TikTok, YouTube, and of course, nautiluslive.org. Thank you.